Right. Hi there. I'm Mirjam from FHIR, and I'm here to tell you about the .NET API. So I'm getting you started on building your own FHIR client. So I've got a couple of slides in my presentation, but I won't do them all because I want you to code with me, right? So I'm just going to go over a couple of details and then we get started. And the presentation will be made available to you afterwards anyway, so you can just review what's in there, what I didn't tell you. And you can always send me an email afterwards if you have questions, or come up to me tomorrow or the day after. And I'll be happy to help you. So we're going to use the FHIR API, which is the reference implementation for .NET. It's maintained by FHIR, but we do get contributions from the FHIR community as well. So there's lots of people collaborating in creating a nice API there. So we are going to have to use a package, of course. So if we are going to start up our Visual Studio in a minute, then you can use a NuGet package. In this case, we are going to take a look at the HL7.FHIR.R4 package, but there's also a DSTU package and an STU3 package available as well if you need to use one of those versions. So all of them are maintained and supported, so they still exist and you can use them. What you get when you have this package installed is that it contains the complete FHIR model. So the model of FHIR that you know from the FHIR website will be in the library, so that will be in the model library. Also, you have a RESTful functionality, so you have a FHIR client that you can use in order to perform calls to a FHIR server. Of course, the FHIR libraries are not only useful for creating clients, you can also use them to create servers as well, because the model is in there, there's validation mechanisms in there, etc. So it's really useful in all kinds of cases. And at FHIR we use those libraries as well in order to implement our Vonk server, our Simplifier platform, our Forge tool. So all of these tools use this same library as well. And if you've talked to one of the Microsoft guys that are walking around here, they use this library too. So it's not just us using it. Please reuse the work if it's there, because these libraries already have so much work in them that it wouldn't make sense to create your own. So going to the model, well, you all know a FHIR resource probably by now, the tree structure we see here. For each of those, you will see that there will be a class inside of the FHIR model. It is a partial class, so if you download the library, you can also add to it if you want. There's a part that's the generated code from the spec, and also we have added some extension methods to some of the classes. So that's why it's partial, so we can easily add extras to it. But if you download the code, it's open source, available from GitHub. You are able to do things like that as well. For each of the required lists of codes that you can use within FHIR, you will see that the library contains this enumeration. So for example, on my slide, you will see that we have an observation status. It has a fixed set of codes, and that's where you will use this enumeration in order to fill the correct codes in. You can't deviate from that. You can't just fill in something else, but that's because the FHIR specification mandates that you use one of the fixed codes. So that's not the library's fault, it's how we've implemented the restriction that's in the FHIR specification. And of course you can, like this, create something like a new observation and then set the status. For some of the classes, we have convenience methods. So for example, for the observation code, that's a codable concept, so that will take a list of codings. But if you create a new codable concept and supply a system and a code, it will already create an internal coding within that codable concept for you. So that makes life easier sometimes. For each of the fields that you encounter in FHIR specification, where you see a 0 to star or a 1 to star list, you will also see this list in the FHIR library. So in this case, the identifier, as you can see, is a public list of identifiers, where the identifier type here is the FHIR identifier. And of course, if you use lists, then in this case, you can use the add in order to add a new identifier. You don't have to create the observation.identifier field first. It will always be there, and then you can just add to it in order to add extra data in it. One important thing to notice is that you have choice properties in FHIR. Those are the things that have this X behind them. So in this case, you will see that we have this value X here on my slide. This is part of the observation definition. And this X means that you have a choice in what data type you fill that field with. So in this case, you can see there's a quantity, a codable concept, etc., etc. The list is longer than this. If you encounter these choice properties in FHIR, then in the .NET library, you will see that these fields are, or these attributes are of type element. Because the FHIR specification or the FHIR library doesn't know beforehand what kind of data type you will put in. So you will have to fill it in by first choosing a data type yourself and then filling in this value field with that data type. All FHIR data types derive from the element data type, so that will work. In this case, you can see an example where I've just first filled in a quantity, so I'm creating a new quantity data type there, fill it in with values, and then I can just set observation.value with this quantity. Because quantity derives from element, this works, but you'll first have to create your own FHIR type and then use that inside of the field. Wherever you see this backbone component element this backbone element on the specification, that means that there's a group of information, a little block of information within the bigger resource type. And for these backbone elements, we have created components in the library. So you will see that there's a reference range component within the observation class in order to have this reference range to be able to fill that in. So you will first have to create a new component block, and then you can fill in the data inside of that. Within the FHIR library, you will see that there are, primitive types and non-primitive types. So for example, we have this active field within the patient. It is of type Boolean. So in code, you will probably just want to fill in a true or a false value. And you can do that because we use the Boolean from C# in order to be able to fill it in. But what you also will see is that you will, this is an example of that, that you will see within the patient model that there's something called active element next to this active, that's a Boolean. The active element, that's the FHIR primitive. Each FHIR element can be extended, but of course, a C# Boolean is just a true or false value. There's no notion of an extension added to that. In FHIR there is. You can extend primitives. So you could create this Boolean and then add an extension to it. But in order to do that, you will need to use the active element instead of the active. So on my slide, you will see that I have filled in the active and I've also filled in the active element. And both will, in the end, have the same value stored inside of it. So when I set active, it actually sets the active element value there to the true value. But the active element gives me the opportunity to add extensions. So that's important to know. You can't just extend a C# primitive. You can extend a FHIR primitive. And you can see that I've created a FHIR Boolean. So for each of the primitives that have a normal name in C# already, we add the keyword FHIR in front of it in order to say that this is the FHIR type, the FHIR primitive type. Okay, so I promised you that this is a Let's Build session, so we're going to build something now, right? So I'm going to switch over to my Visual Studio, and you can code with me if you want. You can also just watch, but coding with me is, of course, a lot nicer. There will be an exercise on the website as well. I'll just quickly switch to that and show you. On the DevDays website, you will have exercises. The one for the .NET is not on there yet, but it will be later today. And it will just do basically what I did now, so you can just take a look at that and do the exercise later if you would like to do that, or expand upon what we did just now. So going to my Visual Studio, I'm just going to select a new project to create that. And I'm just going to create a console app, because for me, for a demo, that's easier just to have a console instead of having all kinds of nice UI. But you can choose whatever you're most comfortable with and then create that project. So this is a live demo, so hopefully everything works. Of course, I need to first add the NuGet package to my project. So I'm going to do that by clicking on Tools and then the NuGet Package Manager. Any way you'd like to do this, whatever you are used to, you can use the console for the NuGet as well. But I'm doing it through this UI. So I'm going to browse for FHIR. And you will see that there's a lot of FHIR libraries there that you can add to your project. For now, it will suffice to just add the HL7.FHIR.R4, which is a little bit down here. So I'm going to add this to my project. If you look at this, you can see DSTU2 and STU3 on there as well. So depending on what kind of version of FHIR you need to work with, you can choose that one. So I'm installing this. I have to accept some things. And then I'll be able to use this in my program. So, well, first thing we usually want to use is the model itself. So adding a new using statement. And you'll see that it's nicely installed. So I can use the model. And this now enables me to create, for example, a new patient. And of course, this is the patient from my library. So if you look at the object browser, you can also check what's in there. So in this case, I would have the model here, HL7 FHIR Model, and you can see the whole list of all the resource and data types inside of there. So you can also check those in order to see if there are extension methods that you can use for that particular class. So going back to my program, I now want to do something with this patient I've created, because it's still quite an empty patient, of course. So we're going to fill this in. So let's fill in a birth date. As you can see, my IntelliSense tells me that there's a birth date and there's a birth date element. So in this case, the birth date, that's the C# primitive, and I can just fill this in with a string, and then of course I have to make sure that this date is correct. But I could also use the birth date element if I want to, for example, extend something on this birth date, then I would use birth date element. And I can fill that with FHIR date time. So, or FHIR date in this case. So I'm just going to do it with the simple one, which is what you most widely would use. And I'm going to fill in a nice birth date here. So we have the ISO notation in FHIR, so it's always year, month, day. It can also be a partial date as well. It's allowed just to have a year in the birth date if you need. So just fill it in with whatever data you would have. Let's do it like that. So now I've got a birth date filled in. So if we now also, for example, would like to fill in a name, you would have the name field in FHIR. But if you look at the FHIR specification, you will see that name is a list. So you will always have a list of names, and that means that you have to add to that list in order to create a new name on that list. So I want to want to add something to my name, but what do I want to add? Well, again, IntelliSense helps me. It says to add a new human name item. So I don't have that yet, so let's just create a new human name. And now if I have a human name, you can see that this, some parts of the FHIR library also have extension methods, and you can sometimes use fluent notation. It's not mandatory, of course, but for human name, I usually take this one in order to quickly fill in a name here. So I can say, okay, I'm going to fill in a given name. So that's my name. And then I can add a family as well if I wanted to. And what this will do is it will nicely set the name.family part to my last name and the name.given part to my first name. Of course, I can add multiple given names as well by just adding more givens to it between the with given, the first with given, and the family that I've put in here. And if I have this human name, then of course I can add this to my patient name field. So I did a presentation about profiling earlier today, and I told people that attended that you will run into having to use extensions. And this is because FHIR uses an 80-20 rule in order to determine which fields will be in your in the data that you can use. So I usually like to fill in my birthplace for patient, but if I would check the list that I have and try, for example, birth, again, you can see that there's no birthplace element here. So in this case, if I did want to communicate that birthplace data, then I would need to use an extension. And of course, within my code, I would want to fill in that extension, right? So the way to do that is to, well, first you will need to know where can I put the extension. You know that by looking at an extension. And I'll just quickly show you the website here, just the HL7 website, and go to patient. So on patient, you will see that this is the whole patient structure, right? You will have this tab called Profiles and Extensions. And if I click on this one, you will see that there's a whole list of predefined extensions for the patient resource type. And in this case, you can see that there is a birthplace extension. This is not part of the 80% because it is apparently not used in 80% of implementations, according to this working group that has decided not to put it in. But since it is still quite common to want to communicate this data, they have created a standard extension for it. So the reason that I am looking at the website now is in order to find out where I can put this extension so I can do it correctly in my code. So I'm going to click on my patient birthplace here. And you will see that there is a context of use added here, and it says use on the patient. So in this case, I'm good if I just put it on the top level of patient. What I'll need to know as well, in order to add an extension, is the canonical URL for that extension. That canonical URL, in this case, you will see it on top here. So I'm just going to select this and copy it, so I'm sure not to make any spelling mistakes there. So I've copied this canonical URL, and I'm switching back to my Visual Studio, and I'm going to add an extension. In this case, because we have seen that we can put it on the top level of patient, I'm just going to do that. So on my patient, I'm going to add my extension. And then you can see that I can fill in a string and a value. And again, that value is of type element because the FHIR library doesn't know what kind of value belongs to this particular extension. So the first thing is easy. I can just fill in my birthplace URL. And the second thing is this value. So, well, I didn't show you, so I'm going to switch back to my extension here. And you can see that it says that the birthplace is of type address. In order to fill it in correctly, I now need to have an address. So I'm going back here, and I'm going to create a new address. For each of the data types, you have a class as well, so just take that class name and you're good. So I've got an address, and I can fill that in with, well, let's just do it like this. I'm used to having a mouse instead of a touchpad. So just to let you see what this address looks like, I have this address created here, and you can see that I can fill in all of the fields that are available in the FHIR address. So for example, I can fill in a city, and the simple one, that's the string field. So in this case, I can just fill in a string. So let's fill in my birthplace. So that's my address. Of course, you can also fill in lines in order to specify further where someone was born with a complete address and a postal code and a state and a country if you wanted to. So adding the address here. So now I've added an extension to my patient resource. Of course, usually this data will not be invented. It will probably come from some database table somewhere or from some file that you've read in, but you get the gist of filling in the fields here. So with me so far, right? Okay? Then the next thing is that you probably want to communicate some data. In that case, we are going to make use of the FHIR client. So I'm going to add another using statement. And in this case, I'm going to use the REST functionality. So I've got the using statement for the REST, and this means that I can create a new FHIR client. So new FHIR client, and then you'll have to supply an endpoint of the server that you want to communicate with. Of course, this doesn't do anything yet, just creating it, initializing the data. It doesn't reach out to the server or anything until I instruct it to do so. But I'm going to fill in a nice address. So on my slides, you will see a link for any test servers that are available. You could use James's Happy Server, of course, if you wanted to. But you can also use the Vonk server, and that's what I'm going to do. That's the FHIR server. So vonk.fhir.ly. And in this case, I'm going to use the R4 endpoint on our server because we are using the R4 library. So this is just initializing the client. I can instruct this client to ask for XML back rather than JSON if you wanted to have that. If you're not bothered by that, just this is enough and you can use the client. But there are some settings on the client that you can use in order to, well, tailor to what you need from the server. So if I wanted to create this particular patient I've just made in my code on this server, I'm going to send it to the server. And I'm going to do that with the client.create. I'm going to have to say which type of resource this is. I know it, but of course my call to the server must be correct, so I need to supply this patient type. And then I can send in this patient resource. So if I run this now, hopefully this will give me a result. Takes a little bit of time, of course, the first time, but it should. Yeah, so it reached my breakpoint. So now I can take a look at the result. So let's just do a quick watch here. And you can already see that this was a successful result because I see that a patient has been sent back to me. If it says anything other than patient on this create, like operation outcome, then you know that the server has sent back an error. But I think that since I do not do any error handling in demos, it would have crashed anyway on that. So in this case, you can see that I've had this result. I did a create, so I've sent my patient to the server, and it will send back the response with the technical ID that this data was created under. So in this case, you can see this ID field here that we can copy the value from. And I already have my postman running, so I can check as well, more low level, if this patient really exists on the server. So let's just check this quickly. Func FHIRly R4 patient and paste in my value. Okay, so yeah, wow, thank you. Usually I spot those mistakes right away, but I'm fortunate to have someone in the audience. So you can see that we have this patient, in this case our FHIR server low-level response with JSON. In your code, of course, you will not see it because it just is loaded in memory. But you can see that this patient does have this birthplace, and it has this name, and it has this particular birth date value that I filled in as well. So they all correspond, of course, with the data that I've put in it in my code. So this was a simple creation of this FHIR patient and then sending it out to the server. And of course, depending on the result, you can do all kinds of nice stuff. I could have also used the FHIR client in order to read this patient in again, but I just wanted to show you low level that it did work on the server. So you have the patient.read as well, and then you will just supply the ID that you want to read, so you can try that out too. So I could, well, let's just stop my code for a bit. Again, if you do a read, you supply the resource type that you want to read something from, and then you will have to fill in the location. So I could have used this technical ID, copy it from my previous patient. That could be from my result. Oh, wow, this didn't copy nice. So I could have done something like this as well, and then you would have the same patient in memory again as you already have in your result. And then you could inspect that. So these methods are all available to you, of course, also for the delete and for the update as well. You just supply the details, and then you are able to get data from the server again, or, well, in this case, we've sent it to the server. So another thing you can do is create a search on the server, which is also nice to do. I'm going to create a new search params object. not a search parameter, because the search parameter is the FHIR search parameter resource type, but for searches we have an extra class called search params, and you can add key value pairs to these search params and then use your search on the client in order to get back the results for the search. So I could do an add, and then, for example, say I'm going to search for a name, and say, for example, something like this. So this could be my search. And then I have to perform the search by doing a client.search. In this case, again, tell the client what you are going to search on. So in this case, I'm going to search for patients and filter on anything that I've put in my query there in my search params object. Oh, let's just keep it like this. So hopefully I didn't crash in this with the read, but we'll see. Yeah, so in this case you can see that I should have done some error handling, some exception catching, because I made a mistake in my, I knew that when I pasted it, I made a mistake in getting the patient back from the server, and you can see that I have this exception here, an operation exception, because it was not found, so I should have done a catch around that, but I could also just comment this one out. Let's try again. So by now there should be a couple of patients that carry my name on the server. So my search should result in something at least. So it has performed the search now. So again, let's do a quick watch on this B. I've called it B for a reason, because if you are doing a search on FHIR, you will get back a bundle, and that bundle has entries, and in the entries you will have the resources that were the result of your search. So you can see that I got back a bundle, and it does have some metadata, but I'll need to find the entries. Oh yeah, there it is. So we have entries, and you can see there are 9 results on my system. And I can click one open. So in the bundle entry, you will find a full URL, which is the real technical ID for that resource. And then you will also be able to see a resource here, and that's the real resource that, well, I'm interested in. So in this case, that will be a patient, and you can see that there's some information in there. Let's see, the birth date. Yeah, this is probably one of my things that I've just sent to the server, because it's the same one. And from the total element on the bundle, you could see that there were more results, and the count of the entries, there were 9, so I could inspect all of them and do something with the data that's inside. In this case, you would, of course, go through the bundle entry by entry and then do something with the entries. Bundles can also have mixed resource types inside of them. So in this case, my search resulted in a list of patients in the bundle entries, but it could also have an operation outcome somewhere at the end if I made some kind of mistake in one of the filters that I've put on there. So don't assume that all of your entries will be patient resource types. So do some type checking first on that in order to really get to the data that's inside. So, well, that was this. I think there are 5 minutes left on this talk here. So what I want to show you is, in this case, our documentation site. So if you would go to docs.simplifyr.net, you can find the FHIR Net API. And there's a little bit of more of an example about what I've just told you, so about the model, about working with the FHIR client. Not too much documentation yet, we are still expanding on that, but you can see some of the things that I've talked about today in this list, and you also have the code example for patient here, so you can fill in a patient like this, or well, take a look at the code and get some idea of what else is possible other than what we've just done. Also, there's an example where you have a code example for filling in a bundle. As I said, the libraries are not only useful for clients, but you can also do server-side things with it. So for example, in this case, you can create a search set bundle as a response to a call that has been made. And that's what this code example for the bundle shows you. Are there any questions? No, this is a beginner session, so that's okay.
So one thing I'm a bit confused about is that you have in your code, you define, or you have the FHIR package, which defines the model.
Yes.
But then there's also an API. Is that part of the same specification? So the API will always be the same? Like you can say get patient/result or something like that? Or
you mean do you mean the RESTful API on the FHIR specification? The REST part of the library implements the RESTful API as it is specified in the FHIR specification. So there's a FHIR specification that specifies the syntax of the calls that need to be done by the client, and our FHIR client in the library knows about that syntax and knows how to perform the correct call. So we as programmers don't necessarily need to know the real get that I did in Postman just now. We just need to use the FHIR client and then say, okay, read this patient for me. And then the FHIR client will translate that into an HTTP call to the server that I have initialized in my client's settings. But what the library does, it does implement according to the FHIR specification. So if you look at the FHIR specification site, you will have this documentation tab here, and then there's a description for the RESTful API. So all of the interactions that are listed here, like the read, etc., we mimic them with the FHIR client, and we perform the correct call according to the syntax that underlies this on this described on this page. Does that answer your question?
Yeah, but then I have one follow-up question, because you say client.read.
Yes.
And then you have the generic specification of patient. And then you put patient also in the URL. Why is that?
Yes.
If you go back to your code. So.
Yes, I know, yeah. So that's how the library has been implemented. So you mean this part, right? Where I have the patient here again. You don't necessarily need to fill it in. So yeah, in this case you have to do it on the if you're searching on patient, you want to fill this in again. I'm not quite sure what the reason for that was. So yeah, I'm sorry there. Yeah. Any other questions? Okay. Oh, yeah.
You said the API covers the client side. If I want to know how the server reacts on this search, is that possible to see here in the next days how the server would receive the URL? It's a sophisticated URL.
Yeah, so if we use the FHIR client methods that I've talked about now, then this will send this HTTP call to the server. Of course, you will need a server running in order to see what kind of call gets in and what the server does with that. But that's definitely possible. You can take a look at our Vonk server. It's not open source, but you can download it and you can run it locally. And then you can, in your log, see what kind of request comes in and how Vonk then responds to that request. So that will just be an HTTP call like it is described on the FHIR website. And also it will just respond. So this is the call that comes in, something like that, but then filled in. And then the response will also be an HTTP response. So it will have a status code, like 404, which I didn't catch in my code, right? Or it will just send back a 200 OK with the body, the patient in this case as the body. And there are more examples of servers that you could run locally. So James's Happy server can be downloaded as well, and then you can also inspect what that server does. That's open source, by the way, but Java, so we're here for the .NET part. So the server will just be a web server. It will accept HTTP calls and send back HTTP responses. That's basically it. But yes, you can definitely see that, and I can show some examples later on if you don't catch one of the talks that does that. So, okay. Okay. Anything else? Well, thank you for your attention. Please find me if you have more questions or play around with the .NET API, get started, and well, hopefully I'll see you create all kinds of nice, complicated apps, more complicated than what I've just done right now. So thank you.